Hi, this is Jordan Stevens and Salase Demeni with Engineering 305, Presentation 4. Okay, so we're going to be talking about control charts. Control charts are a time series graph showing an ongoing process to be monitored. Control charts are used to identify special causes for variance and eliminating it. Typically, variance allows eliminating variance allows better products and lower cost of scrapping or rework. So basically, if you have specification limits, which typically it's set as 3 sigma or 99.7% of the responses, then you're technically in control. But there are some things that technically would lead your data to be out of control in the future. So typically they're called run tests. Typically I think there's 7 types of run tests you do. Just to check, even if all your points are within the specification limits, it still technically could be out of control. And there still could be some cause leading to it. So moving in, we're just going to go to the X-bar chart. X-bar is just the average mean of a set of variables. So typically what you do is, instead of taking one sample every so much time, you take a sample, so like 5 or 6, and you take the X-bar of that, that's the average, and that's what you get as your X-bar variable. And then there's also an R chart. An R just refers to the range of the set. So you take the average, and then you take the highest and lowest in that sample, and then you find that distance between them. Typically, the X-bar / R or X-bar / S, and S chart's just the sigma chart. Control charts are used to see if the process is controlled. Typically, they're used together because you're checking the mean and you're checking the variance on a normal process. So here is a control chart graphed out, just as a visual representation. These red dotted lines are your upper control limits and your lower control limits. The blue line here is the process average. So this is the mean and normal distribution. These are the specification legends on a normal distribution. We're typically associated that it has a normal distribution. So as we see here, there's one point that goes outside of the lower control limit, which is a special cause, which means, oh yeah, we need to check this batch, make sure nothing's going up. Also, we can see that there's many points in a row that are going down. This is typically fails another run test, which is one of the special tests to check it to see if it's in control, and this could be a common cause. So for here, we could say, oh, it's just a common cause or due to normal variation, but this one seems to make sure, with this coupled with that, makes it look like, oh, we need to check our variables. So moving into jump, I chose this airport data. So basically what we'll do is we're going to go to Analyze, we're going to go to Quality Process, and we're just going to do a control chart filter. So since we're trying to measure the amount of delays based on the day, since it's a time series data, we get this control chart here. Now we can see that the specification limits do change after a certain amount of days. They kind of spike up a little bit, but that's fine for at least this model. As we can see, there's definitely something up with these days here, and same with the range chart. Seems like something happened in this time window that we could say, oh, we need to check these 3 measurements and make sure that the chart is in control. So moving on to the next types of charts, we have the UWMA and EWMA charts. So the UWMA chart stands for Uniformly Weighted Moving Average. So typically we choose a span of a certain amount of data points back. We average that, and that is our current point. So basically we take our current sample, take the sample before it and the sample before that, if we have 3, and average them all together, and that's the current point we have. Also, WMA charts typically have a burn-in period just because you don't have a full span yet. It has a burn-in period until that span is reached. As for the exponentially weighted moving average, the EWMA chart, basically this is a chart that samples everything and averages everything together, but the further back you are from the current sample, the less weight or influence you have on the current point. There's also a burn-in period for WMA charts, but it seems to be very similar to the uniformly. So moving into jump. So here in jump, I'm using the CLIPS data. So typically they have the sample, the gap, which is the measurement between the paper clips end and the middle part, and then the status. So to give a WMA chart, I'm going to go to Quality, I'm going to go to Control Charts, and I'm going to choose a WMA. So here what we do, we have our gap as our process, that's the thing we're measuring, sample as our sample label, and let's say, yeah, let's put 3 as our moving average. That's how many points back we sample from. So if we were to click OK, we can see, oh, here's the chart. See how there's a burn-in period for 0, 1, and 2, and 3, and then when it gets to the 4th one, there's no more burn-in period because it's taking the full 3 steps back, 3 samples back and averaging. So each one of these, so this is the first one, this is the first one and the second one averaged, this is the first one, the second one, the third one averaged, this is the second one, the third one, and the fourth one averaged. So it's basically just a moving average chart. And we can see, oh, there's maybe some cause for concern here, but it looks like this series is in control. It seems maybe like it's tapering off. Maybe this could fail a run test of the back. But moving on, we're going to go to the UEMA chart, the exponentially. So let's say we want to do the same exact, and we're going to do the EWEMA chart. So we're going to do quality process control charts, the EWEMA. So we're going to have our gap as our process again. We're going to have our sample as our sample label again. Let's say we have 0.5 as our weight. This is the exponential rate that it will check to see how many far back. The rest of this seems okay. We'll click OK. And here is the exponential. So this is the first sample, this is the second sample with an exponentially weighted first sample averaged with it. And this goes on, so this would be this sample, current sample, plus all the rest of them before it averaged together. It looks like it's falling out of control here on the upper control limit, which may be a cause of concern, and then also it seems like, oh, it's going below the mean line, so it might be some sort of trend here. So moving on to the Pareto charts. Pareto charts are just a modified bar chart that shows the frequency of specific attributes. Those attributes could be defects or failure causes. Typically, the chart also shows cumulative relative frequency to help locate the critical issues. Basically, this shows a bar chart where it has the ratios of all the different types of causes. So this helps you find which cause is the most concerning cause and then cause you need to fix first. So we're going to go into JUMP. So here we have the failure data that we're going to be analyzing. So we're going to click Analyze, Quality Process, and we're going to go to Pareto plot. Our failures are of course going to be our causes, and our N is going to be our weight. So when we click OK, it shows our Pareto plot. So as we can see from here, contamination has the most incidences, and of course it's the number 1 here. So then also we can see the oxide defect has the next most, and it's right here. So it automatically orders them from greatest to least here, showing which effect has the most part of it. And also it shows the cumulative frequency here with this line showing what percentage of all the errors are shown here. This helps you find which causes are important to figure out which causes to look at when trying to fix an issue. So with that, that is presentation 4.